All right, let's start in now and take on another category. In this case, we're going to be looking at applications of the binomial distribution. And I'm going to jump immediately to problem 1. There's quite a few problems here, but you're going to find that these problems, particularly if they're set up like this, as you see in problem 1, A through I, they work like a snap. I'll do some in real time so you can see it. So I will tell you this, that there's two types of problems here. That top box is done with what is called the binomial PDF, a probability distribution function. What that returns when you put in NPX in its argument, number of trials, probability of success, number of successes, is the probability of having X successes out of N trials. The top problem A, if you go to binomial PDF in your calculator, and enter 12.2, it returns the probability of having 2 successes out of 12 trials with a probability of success of 0.2. Okay, that's a little different than the lower box. The lower box is done using the binomial CDF. Now you enter NPX and it doesn't return the probability of a single success, but you'll see it actually what it does is returns the sum of all the probabilities P0, P1 plus P2 all the way up to P sub X. And you'll see, I'll do those last two problems and you'll see how this goes. All right, so let's go ahead and take on this first problem. This view graph is there to tell you that you don't need to have a statistics package to do this. There's the formula for the probability of X successes in N trials. Plug in N, plug in X, plug in P, the probability of success, and plug in Q, which is 1 minus P, probability of failure. Work that out and you can do it. I'm not telling you that that's what I want you to do. I really want you to use binomial PDF. And again, the argument for binomial PDF is NPX. And the reason I stress that is different calculators, some older calculators, you have to enter 3 arguments separated by commas. You have to enter NPX. My calculator, as I'll show you in a second, it asks you for the number of trials, N is what. It asks you for probability of success, P is what. And it asks you for the X value. But in this case, I'm going to do this in real time, and then we're going to blow through this. I'm going to turn my calculator on. I'm going to hit second dist. I've got a ton of things in a vertical menu. I am going to go find, it's actually item A, the binomial PDF. It asks me what's the number of trials, and in problem A it's 12. What's the probability? It's 0.2. And what is the value of X that we're going to calculate the probability for, and the answer is 2. So I tell it to paste that in, and then I tell go, and it says 0.283. 4678415. Right? It's really as simple as that. I'm going to do it again right here. I'm not going to do it for you. Binomial PDF, again, the PDF returns the probability of, in this case, 1 success. When you have 10 trials and probability of success is 0.4. Enter NPX in a binomial PDF and you get 0.040. Let's just go ahead and finish problems C, D, and E, which are all exactly the same. What I'm reminding you here is that what you're doing is you're hitting the second, the blue activates the blue buttons, if you would. Distribution, you're finding binomial PDF in this case. You're earning trials, P and X value, and you're off to the races. And when you do that, you can do every one of those problems. Just that way. Notice the last problem. This would be problem E. It's got a probability of success of 1/3. As you enter that into binomial PDF, feel free to go 1 divided by 3. The calculator will take care of it. So you can kind of add enter fractions rather than decimals if you want. All right, so now when I go to problem F, F is a little bit of a trick. And the good news about F is there's 2 ways to do it. Look what F says. F says, let there be 11 trials. Let the probability of success be 0.5. Calculate for me the probability of 3 not successes, failures. Oh, so how do you do that, for crying out loud? You know, the calculator doesn't know success from failure here, right? It just knows probabilities. So if I changed out that probability 0.05, which is the probability of success, for p equals 0.95, that's the probability of failure, then this top line over here, Bino PDF 11.953, well, that's the probability of having exactly 3 failures. And it comes out a strange number, 5.53 times 10 to the minus 9, a number nonetheless. That's one way to do it. A second way to do it kind of lets you see things a little bit more deeply. 11 says, F says 11 trials, probability of success 0.05, 3 failures. Well, you know what? If you had 3 failures in 11 trials, you had to have 8. If I said that right, if you had 3 failures in 11 trials, you must have had 8 successes. Okay, so I'm going to enter instead 11.058. The probability of getting 8 successes, probability of success 0.05, in 11 trials. 5.53 times 10 to the minus 9. You can do that either way. I'll let you do problem G. You do it the same way. Let's talk quickly about the last 2 problems, H and I. Okay. So H says you got 6 trials. You got a probability of success of 0.35. Find the probability of at least 3 successes. So there's that at least again. At least means this. It's the probability that there are 3 successes, plus the probability that there are 4, because both 3 and 4 are at least 3, plus the probability that there's 5, plus there's the probability that there's 6. We're only doing 6 trials. P3 plus P4 plus P5 plus P6. That is the probability of at least 3 successes. Yeah? So how are we going to treat that? The one way is you can calculate P3, write it down. Calculate P4, write it down. Calculate P5, calculate P6, write them all down, add them all up. You're good to go. But the binomial CDF is meant for problems like this because unlike the binomial PDF, which returns for a value of x the probability of x successes, exactly x successes, out of n trials, that's not what the binomial PDF returns. It returns, if you put in px, the sum of all the probabilities up to and including x, p0 plus p1 plus p2 dot 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 plus px. If I put in, what problem are we doing? We're doing h. If I put in n equals 6, probability of success 0.35, and if I put in 3, okay, that would return P0 plus P1 plus P2 plus P3. Interesting, but not what we want. What we want is this. Remember that the sum of all the probabilities of success has to be 1, right? You're going to run this experiment. The probability of getting 0, 1, 2, 3, 4, 5, or 6, you're going to get one of those values. Right? Either you're going to fail and you're going to get 0, or you're going to get 1 or 2 or 3 or 4. So it's equal to 1. Well, think about what would happen if I took 1 and I subtracted binomial CDF 6.32 from that. 2, that would return P0 plus P1 plus P2. But if I think of 1 as P0 plus P1 plus P2 dot 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 plus P6, and if I subtract P0 plus P1 plus P2, what I'm left with is P3 plus P4 plus P5 plus P6. That's what we want. So the answer to problem H is 1 minus the binomial CDF of 6.352. Because it just goes up to 2 inclusive, right? That leaves you 3, 4, 5, P at 6 is equal to. Okay, let's go to the last problem, I. I says, let's let n be equal to 100. Let's let p be equal to 0.01. Let's find the probability of no more than 3 successes. What does that mean? Well, 0 is not more than 3 successes. 1 is not more. 2 is not more. 3 is not more than 3. So not more or no more than 3 successes means P0 plus P1 plus P2 plus P3. And that is what the binomial CDF is built for, because the binomial CDF of 100.013 is P0 plus P1 plus P2 plus P3. You don't have to calculate those individually. Binomial CDF does it for you, and the answer is 0.98. Okay, so let me cool down a little bit and slow down a little bit, and we'll take on the remainder of the problems in this binomial distribution section. All right, thanks a lot.